Okay, in this problem, we are tasked to solve for the force required to keep B from slipping down. So as I said, you put a piece of paper on your chest. It's never worked for me. Go fast enough and it won't slide down. Something like that. All right. So we can make one statement, F equals ma from Newton's second law. We can see F equals mass of A plus mass of B times acceleration. Now I want to solve the force in terms of things that I can know. I don't know, I can know the mass of A and I can know the mass of B. I don't know the acceleration. Okay? So I have written out the free body diagrams for all this, and for the block A, we have the force of B on A going in this direction, right? Because A is exerting a force on B. B, the third law, according to Newton's third law, is exerting an equal and opposite force back on A. So then we have this force moving in that direction. Now, if this force were the same as that force, I wouldn't be moving in that direction, correct? So I've indicated the magnitude, the size of the force, to be larger than that force. I have the normal force of the floor exerted on A. There's a floor here. It's frictionless, by the way. I have the normal force equal to mg. We're not putting friction on the floor. Okay. Now I have block B. Block B, it wants to slide down. And friction is keeping it up. And it's not moving. So those two forces, the friction force and the mass of B times G, the weight of the block, are equal, right? It's in an equilibrium. But it is moving forward. So the force of A on B is going to equal to the mass of B times A, right? To F equals ma, right? The force pressing on A is going to, I'm pressing on B, which is the force of A on B. That force is equal to mass times acceleration. Okay. So we also know that the sum of the forces here, this is not giving us any information. These two forces do not give us any useful information, right? No. This whole block doesn't really give us any much useful information. What we know here is the sum of the forces here is that we know the force of friction equals N mu S times the normal force, which also equals a mass of B times G. And we know the force, so we also know that the force of A on B is going to be equal to the mass of B times A. All right. I also know that the force of A on B is my normal force, right? Because the normal force here, the force of A acting on that B block, is the normal force times friction keeping the B block up. Okay. So I know that the force of A on B is the mass of B times the acceleration as well. Okay, and I also know that my friction, mu N, is going to be equal to the mass of B times G. So I take N mu S equals M B G. Friction equals the mass of B. Now, I can have N, I've got to rewrite N. N also equals, I'm sorry, I have the mass of B, yeah, I have N equals MBG, and now I'm lost again. All right, N is equal to the mass of B times G, and N is also equal to the mass of B times A. Okay? The N mu S equals the weight of B. But the normal force is equal to the force of A on B, which is equal to the mass of B times acceleration. Okay, so N is going to, so the mass of B times acceleration is equal to N. Mu S is equal to the mass of B times gravity. And I want to solve for A here. So I don't need these masses of B. So A is going to be equal to G over mu S. So I'm going to take this and I'm going to pop that in there. And I've got the force required to keep it up is equal to the mass of A plus the mass of B times G over mu S. It's a little bit confusing at first, right? I was a little confused. Maybe that's why it was so confusing. So anyway, we take all the forces here and we do a little bit of manipulation to solve for this A, which we don't know. But we do know G, and we theoretically could look up mu S. Okay. One more time on this one? Or is it clear? One more time, or is it clear? One more time? Everybody want to see it again? All right. Okay. Here's our scenario. We've got a force. I showed you the demonstration of me walking with the paper. Didn't work that well. I guess I should have run. Anyway, on A, I'm going to have you guys help me out here. What forces are acting on A? Anybody?
B.
Force would be on A. So that would go this way. Okay, what else?
Gravity.
Yep. M, A, G. And then obviously the normal, right? It's not going through the floor. Newton's third law, equal and opposites. And we've got this force acting on it. And we know that it's larger because we have an acceleration in that direction. So from that force, F equals ma, Newton's second law. F equals mass of A plus mass of B times acceleration. Right? We want to write this in terms of things we know. Okay. Block B.